Section 4.7 is on completing the square. And that's what our goal is today. We're going to take, again, a quadratic equation, and we're going to solve this quadratic equation, but now we're going to use a method talking about completing the square. So far, we've used quadratic equations. We've solved by factoring, we've solved by taking square roots, and now we're going to solve by completing the square. So what we're going to do in example 1 is we're going to solve this just like we solved the problems in the last couple days. If we notice, this term on the left side is a perfect square trinomial. So if we would factor this, it would be x and x, 10 and 10. They're both positives, so it equals 81. So if we rewrite this, we could write it like that. And then we take the square root of both sides, and we would get x plus 10 equals plus or minus the square root of 81. Well, this will be x plus 10 equals plus or minus, and the square root of 81 is 9. So we're going to get x equals negative 10 plus or minus 9. Well, negative 10 plus 9 is negative 1. Negative 10 minus 9 is negative 19. So those are the two answers. So that's how we solved quadratic equations in the last couple days. We've been given an equation in this form here, and we have solved them. Okay, so what we're going to do today is talk about another way to do that same problem. But before we do that, let's practice a couple of those. Let's do questions number 1 and 2. So there are your answers for 1 and 2. So now what we're going to be talking about today is we want all of our problems to look like that. So we can do solve our quadratic equations in this same method. So notice here that we always got a perfect square on the left side. That's what completing the square is going to look like. We want these left side of our equation to be the perfect square trinomial, so we can simplify it like that and solve that quadratic equation. So completing the square is the process of adding a term to a quadratic expression of the form x squared plus bx to make it a perfect square trinomial. So to complete the square for the expression x squared plus bx, we are going to add this term to both sides. So if we add it to one side of our equation, we have to add it to the other side of the equation. So we're going to add b over 2 squared to both sides of the equation. So when we look at example 2, they're going to ask us to make this a perfect square trinomial. Well, we have x squared minus 26x plus, we want to figure out what that number is, what c has to be, to make this a perfect square trinomial. Well, we're going to take b over 2 and square it. Well, in this case, b is 26, or negative 26. The sign really doesn't matter because when we square it, it'll become positive anyhow. But we're going to go 26 over 2 squared. Well, 26 over 2 is 13. We have 13 squared, which is 169. So we're going to add 169 to both sides. Now what this does is it makes this a perfect square trinomial. So if we would factor this, we're going to get square root of x is x, square root of 169 is 13. They're both negative. And so that is what we would have as a perfect square trinomial. So let's do the same thing with problems 4 through 6. And that's what we get when we complete the square or find the value of c in these expressions to make them perfect square trinomials. And then if they ask us to write the square of the binomial, that's that part. So now what we're going to do is we're going to use that to solve quadratic equations by completing the square. So if we look at this side, we want to do the exact same thing we just did. We're going to move this 1 over to the other side. We're going to add some number to make this left side of our equation a perfect square trinomial. So we have to figure out what goes in there. So we're going to take negative 10, which is b over 2, and square it. So that's going to be negative 5 squared, which is 25. So I'm going to add 25 to both sides. And the reason is because if you add something to one side of the equation, you have to add it to the other side of the equation. So now we turn this into a perfect square trinomial. And it looks like that. So now again, we are going to do the exact same thing as we did the other day. Take the square root of both sides. We're going to get x minus 5 equals plus or minus square root of 24. We're going to have x equals 5 plus or minus the square root of 24. And then we always have to check, is the square root of 24 simplified? Are there any factors that are perfect squares? And the answer is yes. So we need to simplify that further. So x equals 5 plus or minus the square root of 24. However, 4 is a factor of 24. That's a perfect square. So we're going to have x equals 5 plus or minus 2 square roots of 6. And there's the answer for that one. The next thing we're going to talk about, we're going to look at example 4. Now notice this time the leading coefficient is not 1. To complete the square, your leading coefficient must always be 1. So what we're going to do first is factor out a 3. So if we take a 3 out of everything, it's going to look like that. Well, if we're solving this, we divide 3 by both sides, and 0 divided by 3 is 0, so that's really going to be gone. So now we're going to have x squared minus 12x plus some number equals negative 50. We move that 50 across plus some number. Well, what is our some number? Well, it's going to be 12 divided by 2 squared. 12 divided by 2 is 6. 6 squared is 36. So we're going to add 36 to both sides. Now by doing this again, we make this a perfect square trinomial. X minus 6 goes in here, and negative 50 plus 36 is negative 14. So now again, we are going to have to take the square root of both sides. So when we do that, we end up with, let's go up here, x minus 6 equals plus or minus the square root of negative 14. So we're going to have x equals 6 plus or minus the square root of negative 14. And then we have to check, is that simplified? Is our radical square root of 14, negative 14, simplified? The answer is no. You can't ever have a negative. So it's going to be 6 plus or minus. We'll take out a negative 1. And remember, the square root of negative 1 is I. So we're going to have 6 plus or minus I square roots of 14. And so there is your answer. And in this case, completing the square gives us an imaginary number. So then, let's drop down to example 5. We're going to do the same thing. We're going to find the area of the triangle. It's 144 units. So we're going to set this up using the formula for the area. 144 equals 1/2 the base, which is x plus 10, times the height, which is 2x. So if we multiply these, we get 144 equals x plus 10 times, if I take a half times 2x, it's just x. So then it's going to be 144 equals x squared plus 10x plus, well, that's it. So now what we're going to do is we're going to add some number to both sides. And again, we're going to take their b term. So it's 10 divided by 2 squared. 10 divided by 2 is 5. 5 squared is 25. So we're going to add 25 to both sides. And once again, we're going to get x plus 5 squared. Now, because that is a perfect square trinomial, and the left side is 169. So if we come over here, I'm going to get x plus 5 equals plus or minus the square root of 169. Subtract 5 from both sides. Square root of 169 is 13. So negative 5 plus 13 is 8. Negative 5 minus 13 is negative 18. So our answers are 8 and negative 18. However, in this case, negative 18 is really not a solution to this problem. So our answer is only going to be 8. There's no way that this value x can be negative. It would make this a negative sides. So our answer is C. So let's try a couple of these guided practice problems. Let's go with questions. Let's try 7, 9, and 10. All right, so try 7, 9, and 10. There are the answers for 7, 9, and 10. So again, we want to get the left side always to be a perfect square trinomial. Then we can write it as something in parentheses squared, and we can take the square root of both sides and simplify it from there. The next thing we're going to do, we're going to write a quadratic function in vertex form. So now we have an equation in standard form. We've taken equations from standard form or from vertex form and written them in standard form. Now we're going to do go the other way, and we're going to do the exact same thing. We're going to complete the square. So we have y equals, and then we're going to have x squared plus 18x plus some number. Now, instead of moving the 95 over to the other side, I'm just going to kick it out of my parentheses. So I'm going to write my plus 95 back here. And now, if I added a number to the side, I can subtract the same number from that side. That is going to make it so they cancel out. So that's the same as adding the same number to both sides. So instead of adding a number over to y, I'm going to subtract it from the same side. So again, we're going to go 18 divided by 2 squared. 18 divided by 2 is 9. 9 squared is 81. So what we're going to do is add 81 to both sides. And so really this is going to be x plus 9 squared plus 14. And it is in vertex form. And now the vertex is the ordered pair negative 9, 14. Example 7 says we're going to find the maximum value of a quadratic function. The height y in feet of a ball was thrown up in the air from a roof of a building after t seconds is given by the function negative 16t squared plus 64t plus 50. Find the maximum height of the ball. Again, maximum height is always the y value of the vertex. So we're going to put this in vertex form. Well, to do that, I'm going to factor out a negative 16. So then if we do that, 64 divided by negative 16 is negative 4. So I have a negative 4t plus some number. Then I'm going to move that 50 out of here. And then minus some number. Well, we have to figure out what that some number is. So if we put in 4, so it's 4 divided by 2 squared. So 4 divided by 2 is 2. 2 squared is 4. So 4 goes in this one. Now you have to be careful because 4 does not go in that last parenthesis. Because notice here, this is really a distributive property. We factored out a 16 out of there already. So we factored out negative 16. So we really have to multiply that back into whatever the value we got is so that we can put that in the last space. So negative 16 times 4 is negative 64. So that's the number that's going to go in our backspace. Now we write this in quadratic form in the vertex form, actually. So it's going to be t minus 2, t squared minus 4t plus 4 is a perfect square trinomial. We can write that. Now we have 50 plus 64, which is 114. So here is our equation in vertex form. But they say they want us to find the maximum height of the ball. Well, again, the vertex is 2, 114. And remember, the vertex is always the y value, or the maximum height is always the y value of the vertex. So in this case, our maximum height is 114 feet. So the maximum height of this ball in this situation is 114 feet. All right, so I would like you to do questions 13, 15, and 16. There are the answers for those guided practice questions. Now remember, when we're talking about completing the square, our goal, period, is to solve this quadratic equation. Now to do that, we want to make the left side of our equation a perfect square trinomial. That's going to allow us to take the square root of both sides and use what we learned the last two sections on taking the square root of both sides to solve the quadratic equations. All right, so far we've talked about solving quadratic equations by factoring, by taking square roots, and now this third method by completing the square. Your assignment is on the bottom of the page.